This is Annapurna SK, and today we are here to present about the IPL score prediction from the project-based learning. Here goes the introduction. The Indian Premier League (IPL) is leading T20 cricket league with high scoring and unpredictable matches. Accurate first inning score prediction is valuable for broadcasts, fantasy players, and fans. Machine learning helps predict scores using historical match data like overs, wickets, and run rate. This project focuses on creating a data driven model to predict scores and demonstrate how data analytics can improve match analysis. The objectives are build a machine learning model to predict first inning scores, identify key factors influencing sports over wickets run rate, compare model like linear regression, random forest, or XGBoost, visualize predictions and results, explore future improvements like live data integration. Thank you.
Now, today I'm here to explain about the continued part. That is, first go through the methodology. Here comes the methodology. Let me walk you through our methodology. We started by collecting an IPL dataset containing the match details like teams, venues, players, and etc. Next, we clean the data, like removing an irrelevant columns and converting the categorical values to numerical using label encoding. For normalization, we applied min-max scaling. Then we designed a deep learning model using Keras sequential API. We used a dense neural network trained with Huber laws and robust to outliers. The model was trained for 50 epochs with a batch size of 64 and evaluated using MAE and MSE. Then finally, we built an interactive widget using API widgets to allow users to make a live predictions. Then moving to the next slide, here comes an flow chart. This is the entire workflow of a summarizer visually. We begin with importing a necessary libraries, then we load the data and pre-process the data set. We define our neural network, train the model, and then evaluate it using the performance matrices. Finally, the model is deployed through an interactive widget and predicts the IPL scores based on the inputs like teams, venues, and etc. Then comes the slide that is application. Our model has a real world application across the multiple domains. In sports analytics, it can help teams to adjust the strategies of match. And for fantasy leagues, users can make smarter decisions based on the live predictions. Broadcasters can use the scores predictions to provide a better commentary and insights. Finally, fan engagement increases when our viewers can compare their predictions with the live model outputs. Further information will be given by my teammate Kaustubha. Thank you.
Hello everyone, I am Kaustuba and I am here to explain the code. And here we are importing the Pandas library and NumPy for data handling and Matplotlib and Seaborn for plots and SQL-Learn for encoding, splitting, scaling, and evaluating, and TensorFlow Keras to build and train the deep learning models, and warnings just like silence unnecessary output. And we are loading the data using CSV file, and it likely contains the informations like venue, teams, and batsmen, bowlers, and score. And thoroughly we are dot here it is step 3 is for data pre-processing. uh, the drop IPL dot drop removes the irrelevant and redundant columns like match ID, date, overs, and wickets, etc. Focus is only on the features that matters for the final score prediction, and splitting features and targets. X input features teams and venue and batsman bowler. Y is target like final score to be predicted. And third is label encoding. Um, Label encoding categorical text like team names must be converted into numbers done for when you bat team, ball team, batsman, bowler, and etc. Train split, train and test split. 70% data for training and 30% for testing, and scaling scales all the input features to a 0 1 range, helps the neural network learner better. And the fourth step is defining the neural network. Input layers automatically fits the number of features, and hidden layers 512 neurons RELU and 260 neurons for uh, RELU as well. Output layer one neuron linear because it's regression prediction a number, not a class. And loss function Hubber works well when outliers are present mix between MEA and MSE. And optimizer Adam standard for fast and efficient learning. And fifth step is train and model. Trains for 50 epochs. Full passes through the training data. Uses 64 sample per batch. Tracks both training and validation loss. You also plot the loss to check if the model is learning. And the sixth step is evaluating model. Uh, uh, First one, make the prediction. Predict scores on the test data and clean NANS, removes any prediction that result in NS just in case, prevents crash when calculating metrics. And calculate metrics MAE, average absolute difference from true score. MSE penalizes the large errors more, and lower values is equal to better predictions. And step 7, interactive score prediction widget. Um, Uses IP widgets to make it interactive. Widgets for input, drop downs for venue, batting team, bowling team, strikers, um, bowlers. And next one is predicting. Predict button on click, it encodes the input same way as the training scales the data, making a prediction using the trained model, shows the predict final score right in the notebook. And lastly, we have the output here. The output contains mean absolute error MAE, that is equal to 19.94665. On average, your predictions deviate by about 19 runs from the actual value. And mean square error MSE, which is 729.0195. This is more sensitive to large errors. The higher values compared to MEA suggest a few outliers. And we have drop down menu for venue. And uh, currently the values M Chinnaswamy Stadium and batting team is Kolkata Knight Riders. All of these features have drop down menu. And the bowling team is Royal Challengers of Bengaluru, and striker is CS Ganguly, bowler is P Kumar. There is also a predicted score button likely tied to your trend model for making prediction based on these inputs. And bottom part as the model loss Hubbard, the plot shows training loss and the validation loss over epochs. And the trend is both losses are decreasing steadily, which is good sign. No major overfitting. Validation loss flow follows training loss closely. Loss starts around 32 and drops to below 29, indicating that the model improved over time. And thank you. That's it for my part, and further will be explained by Vinota.
Sir. Now I am going to explain the outcomes. First one, functional score prediction model. A working model has been successfully developed. It allows for interactive input, meaning user can provide real-time data to get prediction. Second, performance matrix. The model was trained using deep learning and its performance was evaluated using common error matrix MAE, mean absolute error, measures the average magnitude of errors in prediction without considering their direction, achieved a responsible range such as 11, 14 depending on the training setup, also within a responsible range like 200 to 50. Interactive tool. A user-friendly interface has been developed. It enables real-time score prediction, likely making it useful in live matching scenarios or predictive sports analytics platform. Next slide, conclusion. Deep learning for score prediction. Deep learning model are effective at predicting IPL final scores using live match data. Generalization. This is important because it shows the model isn't or overfitted to a particular scenario. Interactive interface. A user-friendly interface allows for easy real-time experimentation and prediction. Future information, weather conditions, pitch characterization, historical team or player performance. Thank you.